Hello there once again. Welcome to our Exam Review 3 series. This time we're going to be doing problem 9a on Exam Review 3, where the problem is to fully expand the logarithm log of x squared over 10z. To fully expand the logarithm, the first thing I would do here is count the number of terms. Well, on the top here, we've got x squared. That's one term from there. And on the bottom, we have a 10 and a z. So on the bottom, we have two terms. That gives you a total of three terms. So in the expanded logarithm, we will have three logs. So I'm going to start by saying log of something, and log of something else, and log of something else. Now, if the term is on the top, it will be a positive log. And if the term is on the bottom, it'll be a negative log. Our first term will be x squared. It's on the top, so we're going to allow that to remain positive. The 10 is the next term. Since it came from the bottom, it will be negative, so we'll place a minus sign here. Also, z is on the bottom. Place that in the next parentheses. That's also negative because it was on the bottom. So right now we have log of x squared minus log 10 minus log z. Another thing we can do to continue expanding is to move any exponents down. So this square can come down to the front. I don't see any other exponents here, so we'll have 2 log of x minus log of 10 minus log of z. Now, as far as I'm concerned, this is expanded, but there is one more way we can simplify this. We need to remember that a common log is really log base 10. And if you have log base 10 of 10, that's actually just 1. So we can say this log base 10 is really just 1. So the fully expanded version of this log will be 2 log x minus log z minus 1. And that is how we fully expand a logarithm. Now here's problem 9b. Now we're going to expand the logarithm log base 2 of 8x to the third, y to the fourth, z. The first thing we have to remember is that square root is really the same thing as 1/2 power. So we can rewrite this square root as 1/2 power. So we'll say 8x third, y fourth, z raised to the 1/2. Now we apply the 1/2 power. So now we'll have log base 2 of 8 to the 1/2, x to the 3/2, that's the same thing as 3 times 1/2, y to the 4/2, and z to the 1/2. Now, once again, we count our terms. We can see that we have 1, 2, 3, 4 terms. And since we have no fraction, all of these terms will be positive. Since we have 4 terms, we will have 4 logs. So let's write 4 logs. We have log of the first term, plus log of the second term, plus log of the third term, plus log of the fourth term. In the first position, we'll place 8 to the 1/2, Let's also note that these are all log base 2. We also have x to the 3 halves, y to the 4 halves, which is just 2, and then z to the 1 half. Once again, now that we've counted all our terms, split them into logs, we can move our exponents down. So now we'll have 1/2 log base 2 of 8 plus 3/2 log base 2 of x plus 2 log base 2 of y plus 1/2 log base 2 of z. We're almost finished now. We can't really do much else with the x, y, or z, but we can do a little bit more with the log base 2 of 8. So let's think about what log base 2 of 8 means. This means 2 raised to something makes 8. We can rewrite that as 2 raised to the x equals 8. So we have to think about what power we could put there and make 8. Well, you might recognize that 2 squared would give you 4, which is a miss, but 2 to the 3rd power, 2 times 2 times 2, does make 8. So that means this log base 2 of 8 is really just 3 times 1/2. Or if you prefer, you can say 3/2 plus 3/2 log base 2 of x plus 2 log base 2 of y plus 1/2 log base 2 of z. And so this entire chain here is your fully expanded answer to this problem. Thank you for watching. We'll see you again with another video soon.